Okay, we're going to go through the work for exercise 9D from the Pearson Applied 1 textbook. This is the second part of the SUVAT equations. So first of all, in the previous exercise we worked out the first two SUVAT equations. Now we're going to use these to derive the final three. So first of all, if we look at our first SUVAT equation and rearrange it to make t the subject, then you get t equals v minus u over a. Now if we sub that in for t on our second SUVAT equation, then we can rearrange that by expanding the brackets and simplifying to get this, and then rearrange again. And the usual form of the equation that we're after is v squared equals u squared plus 2as. Okay, so that's our third SUVAT equation. Next one, again using these first two SUVAT equations, so we get s equals u plus v over 2 times t, but then we also know that v equals u plus at. So if we sub that in and simplify, then we get s equals ut plus half at squared. Okay, so there's our fourth one. And our final one, if we go back to similar to how we started that one, but instead we're going to swap u for v minus at, then we get s equals vt minus half at squared. And that's our final SUVAT equation. Now it's important to note there are 5 SUVAT equations, okay, and there are 5 variables in SUVAT. So each SUVAT equation is missing one of the variables. So whenever you're asked to find a missing value, you'll need at least 3 others. So therefore there are 4 values involved, and for any combination of those 4 is one of these SUVAT equations. So let's start applying them. First question, a particle is moving in a straight line from A to B with constant acceleration of 5 meters per second squared. The velocity at A is 3 meters per second in the direction of A to B. The velocity at B is 18 meters per second in the same direction. Find the distance. So we'll start off by drawing a diagram. Again, all pretty simple. 2 particles with the speeds of 3 meters per second and 18 meters per second. Then we're going to write out our SUVAT values that we've got. So we're trying to find S. We know U, we know V, we know A, we don't know T. So we're trying to find S, we've got U, V and A. So therefore we're going to use V squared equals U squared plus 2as. So if we sub in the values we have, and then solve that equation reasonably simply, and you get S is 31.5 meters. Okay. Next example you go through, a particle is moving in a straight horizontal line with constant deceleration of 4 meters per second squared. At time t equals 0, it passes through point O with speed 13 meters per second, travelling to a point A where OA is 20 meters. And we're going to find the times when the particle passes through A, that's times plural. We're going to find the time when it's beyond A, how long it's beyond A. And then we're going to find the time for the particle to return to the origin. So first of all, we'll draw ourselves a simple diagram. Okay, so at point O and point A, the first thing we're going to do is work out the times when it passes through A. So we know the distance is 20, we know U is 13, V we don't know, we know A, and we're trying to find T. Okay, so we're looking for an equation that involves S, U, A, and T. So S equals ut plus half at squared. So if we sub in our values we've got, then we'll have a quadratic in T. Okay, so if we solve our quadratic, obviously first we need to put it all on one side so it's equal to 0, and then solve it. And here we get 2.5 and 4. Okay, the reason we get 2 solutions is because it's decelerating, so it goes through it once and then comes back. So we have 2 solutions. The 2 times are 2.5 and 4 seconds. And for part B, we're looking for the time in total that the particle is beyond A. And if it crosses it at 2.5 seconds and then comes back at 4 seconds, we just subtract one from the other, so it's 1.5 seconds. And then if we're trying to work out the time taken to return to O, So if it's back at O, then the displacement at that point is 0, because it's ended up back where it started from. So we know S is 0, U is 13, A is -4, and we're trying to find the time. Okay, so we sub those values in, and again we're going to have a quadratic in t. And just to check that you've got it right, we know that the first time that is at O is when t equals 0. So when we solve our quadratic equation, we do get t equals 0 as a solution, which is a good sign, and the other value we get is 6.5 seconds. So the time it returns to O is 6.5 seconds. Okay, we're going to look at a slightly more complicated example now. So this time a particle is travelling along the x-axis with constant deceleration of 2.5 meters per second squared. At time t equals 0, it passes through the origin, moving in the positive direction with speed 15 meters per second. We need to calculate the distance travelled by the particle by the time it returns to the origin. So notice this is not a displacement question, this is the distance travelled at that point. So if we start by drawing a diagram, so we know it's going away from O at 15 meters per second and then coming back. So it's going to be double the distance at its furthest point from O. So we're going to work out how far it is to the furthest point, and then we're just going to double that. So if we write out our SUVAT values, okay, we know that V is 0 when it's its furthest point away. T is what we're trying to find. So S is what we're trying to find. So we're trying to find S. We've got U, V, and A. So we can use V squared equals U squared plus 2AS. So we sub in the values we have, and we'll get S equals 45 meters. But remember, the thing we worked out there is the distance to the furthest point. So the total distance it travels, we need to double that. So 90 meters is the total distance it travels. Okay, so that's the end of SUVAT equations.